what is ours and what is not, getting in the end a single number that is a percentage. That is how much that given page is made out of our design system or other components that are not part of the company design system. This is important to enforce brand identity and many other things we will discuss in a moment.
How we did it? Essentially, the goal was to measure the impact of our design systems on the user's devices. So when you visit preply.com, for example, we are calculating how much our design system impacts your experience on your devices. Because of that, we started leveraging all the performance-oriented browser APIs we had just to make sure that we measure our design system on your devices without impacting your UX, of course. I'm Stefano Magni, and I'm currently the tech lead of Preply's design system.
I'm Matteo. I'm too a design system lead, and I work as a front-end architect at WorkWave. So back to the why. Why did we do that? I already anticipated. But what does it mean? Why we did feel we needed that? So most of you, or if not all of you, work on the web development space and probably on some level at UI too. Usually a product team in any given company is able to justify and measure their activities with clear goals. How much our conversion rate improved, how many money we did save on AWS, or that kind of stuff. When you work on a platform team, like a design system team, this is a little more challenging because everybody knows that is an important piece of the company software, and that is something we want to have. But for the leadership, the product owners, is really difficult to translate our effort into metrics that can be used to justify the cost, the activities, and what we do. So usually, historically, if you prefer, we do static analysis. So we can tell the company something like, oh, we add 200,000 or 200,000 too much, 200 button instances across our product. And this is very cool, yes, but it doesn't explain anything to the company leadership. It doesn't explain why it was useful. So what we ended with is, what if we can tell the company, this year, 40% of our web product has been built using the design system, saving time, improving corporate identity, and communicating the visual brands, and that kind of stuff. And that is not just done in isolation. Static analysis is something you still need to do. It's more of a companion of the visual coverage. In the traditional static analysis, we measure the impact of what we do and with the design system over our product code basis. So we identify how many components we use, how they are used, and those are very important information. But they are important for the engineering team, for the people building the design system, to define and decide where we put our money and focus. But from a company perspective, to create strategies, this is moot, is not really something helpful to them.
Yeah.
And this is where we started. This is why we ended with a visual coverage system of our design systems. The visual coverage we envision, and we have now, is a way to present something like a heat map over your web page. We read the page, identify how what we do impact not just the product, but the end users. And from a product perspective, more so if you are rebranding your identity or pushing for a new communication model, this is critical and something that can be aligned with the company goals.
Okay. Is it my
To
turn?
you, yes.
What are we doing? So now you know why we started this project, but what are we doing? So we needed more metrics, more design system metrics, okay, but the requirements were, it must be visual. I mean, we thought that it must be visual because it must be understood from the leadership team. It must be easy to understand, and it must not be technical, because most of the times leadership teams are not technical. Apart from the CTO, other people are not technical. And most of the times, even the CTO, most of the times is not a front-ender. He comes, or they come, from back-end experience. And it must be independent from product teams. What does it mean? It means that, I don't know if any one of you have ever worked for a platform team, but when you work for platform teams, your clients are the product teams. And when you want to do something, let's increase the number of end-to-end tests. Let's increase the coverage of end-to-end tests. Let's migrate our old pages to the new design system components. You always depend on product teams. You suggest ideas, they have to apply them. This is pure friction, because the success of your initiatives as platform team depend on them. This sucks. So the idea was to avoid this. And we started thinking about, okay, let's start from, we must create something visual. We could color the .NET elements on the page. So we started thinking about, okay, we should express the impact of our design system on the real pages. But should we measure the impact of the design system tokens on the real pages? If you are not in the design system space, design system tokens in the end are just CSS variables, just to give you an idea. Should we measure the impact of these design system tokens or components? So, for example, we both built React and React Native components for our product teams. Should we measure the impact of components on the pages? And okay, we know that we want to color the page somewhat with green and red, but what should we color? Areas, border, what? In the end, we decided to draw lines around components, which in the end it means that we are just adding borders around components. As you can see here, this is the basic idea. Let's color the borders. And the final formula to calculate the design system visual coverage is green pixels divided by green pixels plus red pixels. For us, we thought it was a nice idea, because in the end, it gives you a percentage value. So we can always tell you something like, this page is built for 50% thanks to the design system components, for example. It directly measures what the users see. So that's the mind shift compared to, should we check what happens in the code base or should we check what happens in the product? Well, we should check what happens in the product. And the leadership team liked this idea because this made sense to them. We are speaking design systems, we are speaking components, it's something technical, but in the end, they see a product, they see colors in the product, that's fine. They liked this idea. The only caveat, there were a couple caveats for us. First of all, not all the components have the same weight, because different components have different impact on the user experience. They have different impact on what you see, the UI, what you do for the interactive components, so the UX, and a lot of them have a lot of accessibility related things. So not all the components have the same weight. For example, for my company, Preply, the pink button, our primary button, is extremely important because it's connected to your brand experience on our product. So the pink button is more important than a normal text. But a modal or a drop-down is even more important than the button itself, because it has a lot of functionalities. This was better, but not enough. Why? Because the last caveat that we had is that, at least in Preply, in the end, Preply's products are just Preply.com and Preply's mobile application, okay? We have more or less 20 product teams in the company, which means that some pages of the website and some screens of the application are owned by teams. But all the pages are owned by a specific team, but some pages are owned by multiple teams, because, for example, the payment model is for the PayOps team inside all the other pages. So we incorporated into our design system visual coverage a way to split the visual coverage for different teams based on what they own in the page. So how are we doing it?
That was the interesting part.
Yep.
We are all engineers, so this is the more fun part. How do we do it? So when we started, we were really excited and we had a clear idea of what we wanted. Obviously, that changed moving forward with the real thing. But as we started, the first attempt was to just, what if we read the page, we traverse it, we identify what we can identify as ours. There are many ways, data attributes, custom CSS classes, you name it, and translate these into a bitmap, like a screenshot of your page, but just rendering, uh, simplifying red and green colors. Red is bad, green is good, and so this is what we count at the end. There are more nuances to that, and honestly, we ended up with many shades. So it's not just black and white. It's very good, acceptable, barely acceptable, not acceptable. But in the end, it's just, is it ours or is it not?
It worked.
It did work. It was a very satisfying result, and it was working in many different pages. As we said, Preply is a B2C company with a very complex website. WorkWave has a handful of different products that are B2B. So our use cases, our scenario are quite different.
Yep.
But in the end, what we didn't like and what was an issue was the performances. So the first version of the coverage tool was incredibly slow. Like for parsing a single page, it was up to 5 seconds. And worst of all, it wasn't a blocking process. Obviously, that wasn't going to work. Just consider to run in the CI, where you have maybe 100 web pages, and for every pages you have to wait 5 seconds, blocking the process. That means you can run other tests in parallel or whatever. So it's just too slow and too costly. So
No way.
it wasn't going to work. But we sat down and we said, okay, this is not going to work like that. But what if we can change the tool to be as performant as it can be, so we don't care about performances, and honestly, we don't care about CI? What if we run it in production? What if we just run the visual coverage telemetry constantly in the end user devices as they use the product, giving us also a better insight of how the real thing is consumed by the end users? Because while end-to-end tests are good, they are always sort of very controlled environments. We know the hardware, we know the viewport size, and a bunch of other stuff.
Yep.
And this is in the end what we did. So we were able to make it work. And a few benefits, a few good things out of that are that, as I just said, we don't need end-to-end tests anymore. So we have a broader coverage of all the pages with different viewports. Now, end-to-end tests cover all the pages, but it is not that common that you have so many different viewports.
All the pages.
Most of the
Okay.
pages, come on. We try to be better. So, and also this kind of measuring, that it was one of the original goal, it aligns with the company vision and goals and can be included, incorporated in roadmaps and priorities
Yep.
for the development. Another important fact is that that made us not completely, but mostly independent by the product teams. That for a platform team is an incredible benefit, because normally when you build something internally, you have to wait your colleagues on the product team to have the time to upgrade and adjust to the newest version of whatever you did. And most of the time, these happen weeks, if not months, after you do it. So it slows down all the process. Injecting the coverage in the design system,
Yep.
we need to the product team for upgrading to newer,
In,
uh,
in the end,
but it
the
works.
change is, instead of asking them, can you can you count, can you measure the design system
Yep.
on your pages? Instead of saying this, we can say something like, hey, we know that your team uses the design system only for 10% of your pages. Well, it's quite different.
Don't be so accusing.
Sorry. Oh, I know that your team uses the design system for 90% of your pages. That's way better.
Also, you have preferences.
Okay.
I see. Please continue.
Let's speak about something technical. So, first of all, quick demo. I'm gonna show you what Preply's developers can do on Preply.com. You can also do the same, because in the end you can do the same, because we are exposing some global functions on the DOM. So for example, if in the browser DevTools, I'm gonna execute this function, run and visualize, I can show you how much, for example, this page is built with design system components. More or less, green is the design system, everything else is not the design system, just to simplify the idea. And the result is, well, nice. We have two different containers because this page is owned by two different teams. One of the container use the design system for almost 90%, and also the other one. Wow, that's fine. The name of the team, comms team, and matching team. Nice.
Terrible naming choice.
We can do the same on all the Preply.com page. Okay, in this example, this is the chart I had with my tutors, and I can show you that we have two containers, 80% and 86%. The design system impact 86% of this page, for example. But let's go a bit more technical. Again, this is a simplified example, but we want to tell you how we did it so performant, essentially. Here you can see a small page. Here you can see the result of what it means for us to scan the DOM elements. And here, this strange idea of let's recreate the bitmap. So for example, when the visual coverage library starts, it finds that there is a container around the whole page, okay? And we mark the container with red because it's not a design system component. So we track the coordinates of this element and we recreate a sort of visual experience of the design system in a bitmap. This bitmap is just a long array, a very long array when we add colors to identify elements. That's it. Next step, we find that there is a heading component. This component comes from the design system, okay? We track the coordinates and also the component name. This is a heading. And we are going to update the bitmap. And the library goes on and find one text element from the design system. We track the coordinate, we update the bitmap. We find the button. This button doesn't come from the design system. Okay, that's fine, but let's mark it as red. And then we find a pink button. This pink button comes from the design system. Let's update the bitmap again. But wait, I told you, for example, that the pink button for Preply is more important than the text component and the heading component. So let's increase the weight of this component in the page. Let's track the weight when we scan the DOM elements, and let's update the bitmap. In the end, the calculation is we have almost 120 green pixels, almost 50 red pixels. The visual coverage is 70%. That's it. This is the calculation. This is the basic idea of how it works.
So what Stefano described now was like a synchronous process. In reality, is a two-steps process. We first, in the main thread of the browser, traverse the DOM using CSS selectors, data selectors, and whatever you need. The system is configurable.
Yep.
So actually, at WorkWave, at Preply, we use different logic to identify what is what and their weight. No problem. And after we traverse and identify what is what, we create data that are then transferred to a web worker, and the web worker will generate a bitmap. But before we go into the bitmap part, what we just described was the very simplistic process. But doing it, we identified that to make it non-blocking and performant, we needed to do some adjustment. What saved us for the most are request idle callbacks. I don't know if you know about the API, is now available in most of the browsers, is like request animation frame, but the biggest difference is that it tells you how many milliseconds you have at disposal before the idle callback will end. So you can create chunks of your work and pause and resume the process as you need. And this is very important because while the real process, as we'll see later with numbers, is very fast, the actual time could be seconds, but split in many small idle callbacks moments. That make it very effective. But it also forced us to make the system quite resilient to change in the DOM, because in many seconds, the web page, the DOM could change. And so maybe a node we were traversing is not anymore. So this is something the coverage accept and just move forward. In, in the big picture of hundreds of thousands of collected data,
Yep.
a few Frankenstein pages are not affecting the overall result. Drawing the bitmap. So as we said, we collect a lot of data that we transfer to a web worker, because the second part, it doesn't need to be in the main thread, and so we can um, be safer without affecting the user experience. What we do is creating a bidimensional array of rows and columns that represent the bitmap-like structure, and we color code every position, as I said earlier, in the simplest way with red and green, or as many shades as you want to identify your stuff. Another thing important is that as we draw, and we saw that with Stefano and his example, is that we try to follow the Z index of the page. Not exactly, but as much as we can. That means that the innermost element are more closer to the user, and they come with a higher weight, a bigger weight than the one behind, because they are most non-guaranteed, but probably covered by
Yep.
it. That was good, but not enough. And we asked for help. And Massimiliano, that was also here yesterday for another talk, helped us a lot. Yeah, this guy in the first line. And Massi, for the one doesn't know, worked also in the VA team. So he really has great insight on how to optimize that kind of processes. And a few of the suggestions that he gave us are to switch from a bidimensional array to a monodimensional array, uh, reducing the cost of retrieving the data during the process and storing it. Also, to switch to use a typed array. Aside being more memory efficient, it allowed us to share the buffer between the two threads, avoiding to serialize the data when sending it from the main thread to the worker thread. And finally, it pushed us to remove as much as possible branching condition, because the more the code is branch free, the more V8 is able to execute it with C-like performances. It's not like the real C code, but it's way faster than traditional conditional JavaScript code.
It was crazy.
It is. This is
So
all great, but please,
let's speak about the numbers. In the
exactly.
end, we cared a lot about these numbers. So we told you that the first implementation with the screenshot took 5 seconds for a big page. When we implemented our solution, well, we optimized it, and in the end, it was just taking 50 blocking milliseconds. That was good, but not perfect. But after applying Massimiliano's suggestions, we moved it to 35 non-blocking milliseconds. Of course, we are still speaking about our MacBook Pros, so very expensive devices. But we also measured what it means to calculate it on all devices. For example, the Huawei P9 is a 10 years old budget phone. And we tried it on the same big page. It takes 900 non-blocking milliseconds. 900 milliseconds is a lot, but who cares? Because it's not impacting the user experience. That was our goal, and it was perfect for that. Was it worth it? Yeah, yes, because the design system visual coverage, FYI, we open sourced it, but the design system visual coverage library is 100% plain JavaScript. It doesn't depend on any framework. It can run so on any web application, and it's highly configurable. For example, Preply and WorkWave have very different contexts. We are a B2C company with 2 products. They are a B2B company with a lot of products. We have maybe millions users per day. Maybe you have 10,000 users per day.
Yeah, 100 probably, but not millions for sure.
Okay. We have a lot of teams working on the same front end. They have many teams working on different products. But in the end, and also our design system components are extremely different because they are based on MUI. We built everything from scratch. But the cool thing is that the design system visual coverage is highly configurable. It's up to you to configure what it means to identify the design system components and specify the different weight for every single component. And what have we done so far? So we previously beta tested it in production. This has been in production for the last 1 year and no issues with that. On the Prep Engineering blog, you can find 2 exhaustive articles about the why, the what, and the how. So also there you can find all the implementation details. We open source the project. So it's under Preply organization, but you can use it for free, of course. We made it because we want you to do the same. If you need it, we want you to do the same with our library and getting feedback about it and getting it better and better. We are also, it's not released yet, but we are also implementing a Chrome dev tool to help you working with the coverage, because in the demo I showed you what it means to launch the design system visual coverage from the dev tool, but in the end it's just calling functions. Having a nice UI around it would be quite better. Matteo is scaling it a WorkWave. It's still not in production, but
yeah, we have some exploring phase to
yeah.
do, but yes.
And we are also chatting with other companies. So a couple of companies like DocPlanner and Monday.com showed a lot of interest for this tool, and it could be that we are going to help them to adopt it in production on their websites. What about React Native? Because as I told you, Preply has Preply.com and the mobile application as the main products. Well, in React Native doesn't offer the same performance-oriented API that we have in the browser. And also, traversing the DOM is not so simple, because in the end, the browser is an open platform. You can do whatever you want. It's not the case for React Native. So we are collecting the visual coverage events and data on our mobile application, but using a more conventional approach. In the end, luckily, Preply has a high coverage event test for the mobile application. So that's why we incorporated the visual coverage into the end-to-end tests. And we also wrote a small Swift function just to extract all the coordinates of all the elements in React Native. In the future, they are going to expose more APIs that could allow us to do the same. So collecting visual coverage data on the production application on users' devices, but it's not the case yet. And
Yeah, we still have time.
Perfect. Let me show you. I showed you what it means to run the coverage in production, but let me quickly show you the dashboard that we built in Preply. So for example, here you can see 2 big numbers. This is what the company cares about, okay? 76% of Preply.com is built with the design system components. Nice. This is what they care about. This is what the leadership team wanted in the end. But as the design system team, honestly, we are more interested in the data for each team, because again, each team has different pages, different needs, and they use the design system components in different ways. And also what it means for every single page. Just to give you an example, do you see this corporate dashboard? We can see that in the last month, they decreased the usage of design system components by 50%. Well, let's investigate why. Maybe they are running some experiment that is not covered by the design system components. Let's check. We can see how it's going with all the pages, etc., etc., etc. Just one small thing that we didn't mention. The design system visual coverage is a monitoring metric. What does it mean? If I tell you that the corporate dashboard decreased by 50% the usage of design system components, let me be honest. It's nice because we are tracking it. It's a bit too late, because it means that the product team for the corporate dashboard decided to go for a different UI. The designers designed this UI, the developers implemented the UI, the developers pushed the new UI in production, and now it's in production, and we know they are not using the design system components. To be honest, it's a bit too late. That's why I'm calling it a monitoring metric. So, and it's not the only metric that we have in Preppy. To be honest, we have the visual coverage, which is high, very important for us. But also we are tracking the NPS score with our users. We are tracking the static analysis data, like how many times our components is used in the code base. So the design system visual coverage is not the only metric. It's an important metric, but not the only one. I think that you should have this and also other simpler metrics, maybe.
Yeah, another thing important to consider that probably you forgot
Yep.
is that is a living thing. You can think about it like more like the stock market, because depending on the day and also your product, it could be that today I don't know, the home page not, but the chat page is 80% covered, and tomorrow or next week, maybe probably, is 70 or 90. This fluctuation is because we read data in production on the user devices. So if we scan the page when the user is on an empty chat,
Like this, for example.
the values are way different if we scan the page with a full chat. And because we do that programmatically at probably at least every 10 minutes period, we don't know what we are reading. So the numbers goes up and down continuously, and maybe around Christmas they are higher than, I don't know, 2 weeks after. So as we say, this is a monitoring data, something you use to complement the other information you have. It's not just the single source of truth.
Yeah,
And that's it.
that's it. So both.